Welcome to Iron and Steel Making course lecture 16. Today I am going to speak about the problems encountered in recoverable coke oven batteries, which I taught in the last lecture. The problem in this situation is the compaction of coke is happening automatically in the coke oven battery chamber, which leads to the situation called there will be the variation of compaction at top and bottom. Top it will be the loosely packed, in the bottom it will be the closely packed, which leads to the finally bulk density variation over thickness. Now in that situation, what are the solutions to overcome this problem? The solutions exist. You preheat it and form a briquetting mixing with a binder, initially the coal at the cold stage, and selectively crush fine size and coarse size. These are the solution for this problem. Now I am going to teach next point, that is non-recoverable coke making process, which has other name BehaviorCoke oven. Basically the schematic of this BehaviorCoke oven is like this. This is header pot, that is top. This is bottom pot, indirect heat transfer from refractory line bricks. This is a kind of a bowl. The bottom is where the coal cake is formed, which is nothing but coke, and directly the heat transfer is going to top, and from the downcomers you are sending these particular gases, reducing gases which evolved and which is been passed to these particular refractory bricks. You store it, you regenerate, you can regenerate, but most of the gases are escaping out. This is a practical top view of this BehaviorCoke oven, and the problem and the significance of this particular BehaviorCoke oven is it is more wide and flat, inside flat, and it is environmental friendly, but you need to have more and more this particular BehaviorCoke ovens batch type, and production cannot be reached to the expected, and it will take 48 hours. Now let me emphasize one point about the BehaviorCoke oven. What are the disadvantages? Advantages for the recoverable coke oven batteries, there are many, and limitations, solutions are existing. Any technique, it has disadvantages. Advantages, the technique is developed mainly for advantages. Here we need to emphasize disadvantages. The disadvantage is the output when you compare with the recoverable coke oven battery, output blast furnace quality of coke is poor, and there is no generation of coke oven gases. Just like in the recoverable coke oven batteries, these coke oven gases which are produced largely utilized as a fuel in the subsequent process of steel works in the integrated steel plant, and productivity because of the chamber dimension, BehaviorCoke oven chamber dimension, the productivity, volume of the productivity end product is very low, and you need to have more land, whereas recoverable coke oven, it is automated, chambers are and compacted, long length instead of long wide. That is the advantage of recoverable coke oven. Here in this situation it is wide, so you need to have more land, more space requirement, and partial burning of the coal at bottom of the location side wall, you cannot avoid it. It may leads to the final yield of coke, 1-2% of coke yield is reduced because of partial burning, which cannot be, partial burned coal cannot be converted into the coke, which cannot be used. That is one point. The other points are, let me speak about what are the functions of coke in the iron production process. It is a fuel, and this particular fuel is endothermic fuel, and which can be used, this particular heat, to melt the slag and to melt the molten metal. That is one function. It produces and regenerates, reduces gas. What does it mean? It produces, because of the combustion heat situation, it produces the CO and it regenerates the CO2, which can be used as a reducing gases in the iron making process. Now coming to the, it provides open permeable bed to pass the slag and to pass the metal through from the upwards to downwards during the iron making process, pig iron production in the blast furnace. Permeable bed it provides, the coke provides, and it supports for overlaying so much weight of the burden at lower levels such as blast furnace, earth pot, even at higher temperatures achieved. It supports this particular coke. This is one advantage. The other thing is, it immediately carburizes as it reaches to the combustion stage of coke. It carburizes the iron and it lowers the melting point, so that at lower melting point, at lower temperatures, you can melt down the iron. You no need to go for the 3000-4000 degrees Celsius. Even at 1500 degrees Celsius temperature, you will melt down and you can take out the slag separately and molten pig iron separately. And finally, the cost effective point. Cost produced investment for production of pig iron is different. In the entire production of pig iron, 60 to 75% of cost you need to spend on converting the coal to coke. That point one need to keep in mind. Now, properties of coke. What are the properties of coke? Let us talk about chemical properties. It has reactivity when it comes in the contact with the iron. It has ash content. It forms the ash content, which is other byproduct of carbon. And chemistry, sulfur, phosphorus varies, and reducibility, size reducibility, and reducibility in the form of converting the gases, CO reducibility gas, reducible gas, CO2 reducing agent, and which these gases reduces the iron ore to iron, Fe2O3 to Fe. So that is the other point. Coke reactivity index. There are certain standard parameters. What is the reactivity index? It can be calculated, which I speak in the next coming lecture. And coke strength after reaction. After reaction is happening within the during the pig iron production, how much is the coke strength is having, even when it is going to the higher temperature, all those particular points. Now coming to the physical properties. What are the physical properties of the coke? Room temperature, high temperature strength. What is the strength? When it is at the room temperature, as the temperature is going down, what is the strength? What is the burden lying capacity of the coke? Shorter index. How do you calculate the shorter index under the impact load, which will be discussed in today's lecture in few minutes. And tumbler or abrasion index. Due to the abrasion of coal, how much sustainability is retaining of coke. And compression strength during the storage of the coke before production of iron. Due to the lying down for the storage, what is the compression strength of the coke will be discussed these particular properties will be discussed in the next few minutes. Now other properties, porosity, what is the porosity value, and what is the swelling action, lower temperature and higher temperature, what is the size variation, volume, particle size, coke particle size variation. All these things one need to have the clear idea about these physical and chemical properties of coke. Now let me take one example to assess the coke quality of which is used for the blast furnace pig iron production in Northern America. The situation is, the properties may be, for example, coke size. The average supposed to be 52. For the good quality of coke, range may vary, and plus 4 inch by weight, plus 4 inch size 1, and minus 1 inch size by weight, percentage by weight 8, which is considered as a good quality. And coke reactivity index, stability, the number, coke strength after reactivity, average 65, and percentage by weight. For the good quality of coke, these chemical properties supposed to be this much: ash content 8%, moisture content, minimum moisture content is required 2.5, sulfur 0.65, volatile matters, volatile elements, oxides, alkaline matters 0.25, phosphorus 0.02. Even then, for the good quality of coke, you require higher fixed carbon, high carbon content, but not these other components such as moisture, ash content, sulfur, phosphorus, alkaline, which are undesirable, which are not supposed to be higher, supposed to be minimum. These fixed carbon supposed to be carbon, one of the property which gives the thermal heat, thermal conductivity, calorific value of the coke, which is decided by the carbon. So that's why it should be more. Now let me talk about the strength. How do you assess the strength in these particular two techniques, recoverable coke oven and non-recoverable coke oven? How does it is being influenced, the strength of the coke? The points as discussed: mixing ratio, proportion of fine size, large size, proportion with the binder and coal. What is the ratio? Proportion is one of the property which influences lot. And coke particle size, how does it is distributed? Is it uniform or non-uniform while charging the coal, and while the conversion of the coal to coke? All these things matter of interest. And coke oven temperature, what was the temperature utilized during the carbonation, combustion conditions, does it producing the reducible gases or not, and moisture content, is it low, soaking time, how much time is allowed, is it 24 hours just like recoverable coke oven, is it 48 hours in the non-recoverable coke oven, and width and height of the chamber of the box, the height is large in the case of recoverable coke oven, where in the case of non-recoverable coke oven it is wide, flattened dimension. And method of heating, fuels and reactions, endothermic reaction, exothermic reactions, what fuels are regenerated, regeneration principle is all the parameters which influences the strength of the coke. Now let us take few properties to decide about the strength of the coke. The strength of coke can be measured. Measurement comprises shorter test for knowing due to the impact load, how much strength, how much resistance it has, susceptibility, and tumbler or drum test due to the compression load. So how much susceptibility it has. Compression test due to the storage load, compression strength. Now let us talk about shorter test. The shorter test is mainly the aim of the shorter test is it gives an idea what is the susceptibility to breakdown due to the impact load during the loading and unloading, charging into the furnace, even during the transporting. All those things are very important. One need to address this particular issue also. The procedure to calculate shorter test is you will be taking the standard weight of the material. It could be the 1 gram, it could be the 10 grams. It is allowed to fall on a steel plate from a standard weight. It could be the 1 meter, it could be the 1 meter, it could be the 10 meters. With predetermination of this standard height and standard weight, with repeating for number of times, you will be calculating the shorter test resistance due to the impact load. And normally the statistics from the industrial experience, the strong coke for the impact load from the shorter test plus 10 mm size is about 80%. And coming to the shorter test, how does it is calculated? This is typical apparatus used for the shorter test to know the impact strength of coke by shorter test. The amount of material is standard and weight, height also standard. Then you calculate shorter index with, for example, if it is plus 10 mm size particles, you use weight of the initial weight, how much kgs you have taken, 1 kg for example, and mass of the coke retained after falling from this standard height 10 meter height within this particular steel plate, how much 10 mm size particles are retained, and this is how much plus 5 mm size particles are retained. That is retained weight of 5 mm size is W3 and retained weight of 10 mm size is W2. This W1 is initial weight. You calculate with this particular principle. Now coming to the tumbler index or tumbler test or abrasion test. The aim of this particular test is you are going to know, you are going to determine or measure the susceptibility of coke to break down due to the abrasion load while handling, moving from year and year, while charging, transportation into the blast furnace bells, lower bell, upper bell, in the top bell charging system. So all those things are matter of interest. There will be a abrasion which occurs. What is the breakage percentage? How much percentage of coke retains even it undergoes the abrasion of at certain stages. The procedure, standard procedure for this thing is also you are selected the standard weight, for example 1 kg. With the selected range, uniform size of the coke is selected and it is rotated using a drum with a standard number of revolution. For example, 10 times, 10 kg of weight 10 times with the uniform size of the particles. 10 mm size of plus 10 mm size of particles are taken and calculated, and the industries gives a statistical value. The abrasion strength of coke is, and for the plus 6.3 mm size of the particles, as it is goes to the abrasion, it is 80 to 98%. Plus 6.3 size particles retains. If it is lesser, it is going out as a waste, as a fine particles. That is one statistical value. How does this particular test is done? This is a drum. You allow for using the controllers. You rotate for the number of revolutions. How do you calculate this particular tumbler index, abrasion index? These particular things are corresponding. This is mass of the sample before test. After abrasion, M1, after abrasion, how much plus 6.3 mm size particles are retained in the CU, and M2 is how much is passed through and how much is retained around 500 micron meters. That is gives for the this particular abrasion index. Abrasion index you need to have how much is retained, how much is passed through. You will be considered both the things. This is initial mass. This is initial mass. This one is for the tumbler index only how much is retained is good enough to calculate tumbler index. It is different tumbler index calculation and abrasion index. Please note this particular point. And coming to the compression test. What is the aim of the compression test? How much susceptibility the coke is having not to break under the compression load while it is stored for longer time before starting the operation and before going to the while transporting also it is storing at the within the bin. What is the compression strength without losing the fine particles under the compression strength, and what is the burdening capacity inside the blast furnace? You will be knowing from this particular test. This is how you will be preparing the standard size particles, maybe 10 mm into 10 mm size, 10 mm diameter and a 10 mm height particle, and you calculate the compression strength using this particular standard test, ASTM dimension test or ISO. These particular tests are utilized especially, which gives automatically gives the compression strength values. It can be utilized for the iron ore pellets also. Mainly in this situation we are using for the coke, and the procedure is the coke is reduced at a different degree level. You will be allowing you will be doing for the room temperature and air temperature. How much plus 5 mm size particles are retained after doing this particular strength test? How much plus mm size particles are retained? So you will be take out that particular sample, bite that sample, you will remove it, you will loosely pack it, you sieve it. How much plus 5 mm size particles are retained? That much particle size having the good compression strength. That is one indication. Now coming to the few questions in concluding this particular today lecture. Those questions are as follows. What is the difference between coke oven batteries recoverable